That's definitely not a number display method. Nothing at all to do with time in number displays. I'm trying to find the rest of my number display code, and it's back on slide 19. So let me make a list here. This is the order I would read these slides in. I'm going to do it with you here. The number display code, slides from lesson 6. I would look in quite a different order than what they're listed. I would start with, let's see, slide 12. Slide 19. Slide 22. Okay. 12, 19, 22. And on slide 22, I'll also make a note. Plus, there is another method, which is not displayed here, public int get value, used for arithmetic. I'll talk about that later. Okay, so after you're totally done looking at the number display, it's time to look at the clock display. So let's go back to slide 12 first, finish off the number display, then we'll have a new video for the clock. Slide 12. My number display has nothing but a limit, which is the maximum limit it never quite attains, and the current value. Slide 19, we can see when you make the number display, it always starts at 0. 0 miles, number 0 in a deli, 0 o'clock, 0 minutes, 0 hours, day 0. Whatever your number you're displaying, this constructor starts with a value of 0. And then you can say how high to go. For example, 24 for hours, 60 for minutes, 1,000,000 for your car odometer, 100 for your deli, if you want people to line up from number 0 to 99 only. In increment, which I would like to call increment nicely or increment properly, you can see it goes up and then gets modded. Let's see what happens here. It's not a big deal, but let's see. Let's say the value is 58 and the limit is 60. You're keeping track of minutes. Okay, when you call increment, the value will get 58 plus 1. That's 59. And the modulus means the remainder. When you divide 58 plus 1, which is 59 divided by 60, okay, 59 divided by 60 is equal to 0, remainder 59. So the value goes from 58 to 59 when you increment it. However, if it's sitting at 59 and you increment it, 59 plus 1 is 60. $60 divided by 60 is equal to 1, remainder 0. And the modulus is only the remainder. So after you go from 59 and you increment it, it would go to 0, which is exactly what happens on our clock. The minutes, if you just watch the minutes, it goes 58, 59, 0. And then you'll see the hour changes. But the minutes go from 58, 59 to 0, 1, 2, 3, etc. So the increment is nice. It doesn't merely increment. It also makes sure you never go past or up to, for example, 60. I'm thinking of the example of incrementing minutes on a clock. If this were hours on a clock, it would look something like this. 23, start even earlier, 22 plus 1 is 23. Remainder after divided by 24. Okay, if you increment 22 on a 24-hour clock, 22 goes to 23. 23 divided by 24 is 0. Remainder, all 23. And this is the modulus. So if you increment 22 you end up with 23. If you increment 23, that goes to 24. 24 divided by 24 is 1, remainder 0. And this is what you get from modulus right here. So if you increment 23, you end up with 0. And the next time you increment, the 0 would become 1. And if you increment from 0 to 1, you get 1. If you increment 0, you get 1. If you increment 1, you get 2. If you increment 2, you get 3. If you increment 23, you go back to 0. So the number display seems to work. It has nothing at all to do with clocks. It works with any limit, any value. You can get its value using this, or I'll just put it in here for now. The other version. Return value. It's in the notes. So this is the one you want to do arithmetic on when you're in the clock later. Sorry, this is called get value. It's already there. Okay, so to review, I'm dealing with a number display. It can be used with a clock. It can also be used with a million other things. If you look at slide 12, you'll see what the number display is made out of, namely a value and a maximum limit. If you look at slide 19, you can see how it increments things, possibly rolling over when it gets too high. And if you look at slide 22, we can see that you can grab the value. Finally, I'm going to create my clock display in the next little video, and you'll see it's made of a couple of these number displays with different limits and different values. For example, right now it's 2:15 p.m. So this would be 2, this would be 15. In fact, it's 2 p.m., so this would be 14. I'll review this clock display, or actually start the clock display, in the next video.